Okay guys, our last lesson we talked about how to simplify square roots. Today we're going to talk about how to simplify cube roots. Alright, so let's talk about what the difference of that would be. When we talked about perfect squares, that means that any number multiplied by itself would give me a perfect square. So for instance, 5 squared was 25, right? 25 is a perfect square. You could also say 16 is a perfect square, or 9. With perfect cubes, it means that we're multiplying a number times itself 3 times to get a perfect cube. So the cube root of 8 would be 2. Okay? 2 cubed, or 2 times 2 times 2 equals 8. The cube root of 27 would be 3. 3 times 3 times 3 is 27. The cube root of 64 is 4. Because 4 cubed is 64. The cube root of 125 is 5. Hopefully you're starting to see the pattern. 5 cubed is 125, right? And lastly, the cube root of 216 would be 6. Or in other words, 6 cubed is 216. Okay, we can keep going from there, but that's just to give us a little overview of what a perfect cube is. But what happens if it's not a perfect cube? Okay? We're going to simplify cube roots just like we did in the last lesson with simplifying square roots. What we're going to do is divide the radical by its prime factors. And remember, we listed out prime factors last time. Our prime numbers would be 2, 3, 5, 7, 11, 13, and so on. A prime number is any number that is only divisible by itself in 1. Now this time, since we're talking about cube roots, instead of circling every pair, we're going to circle every group of 3 like factors and bring that outside of the radical. Whatever's left over is going to get multiplied and left inside. So if we take a look at this first example with 108, if we're trying to get the cube root, we're going to start by dividing by prime factors. Well, I know that 108 is divisible by 3. That gives me 36. 36 divided by 3 is 12. 12 divided by 3 is 4. 4 divided by 2 is 2, and we stop there because it's a prime number. Now, if you notice, I've got 3 3s circled. Because I have a group of 3, I'm going to take those out and leave whatever's left behind underneath the radical. So in our answer down here, we have that 3 that got pulled out, that group of 3. And then my 2's were brought down here. They're left inside, and we're going to multiply those together because they are factors, right? So our final answer would be 3 cube root 4. Okay, so if we take a look at this first example, we're going to start to divide this by our prime numbers. So I'm going to write 320 right here. And we'll just start by dividing by 2. That's a nice, easy prime number to use. So 320 divided by 2 is 160. And we can divide that by 2 again, and we would get 80. We can divide 80 by 2 and get 40. 40 divided by 2 and get 20. 20 divided by 2 and get 10. And 10 divided by 2 and we get 5. Okay? Once we get to 5, since that's a prime number, we're going to go ahead and stop there. So now I want to look for my groups of 3. Well, I have a group of 3 here, so I'll bring that out. And I have a group of 3 2's here, so I'll bring those out. And then left over, I've got this 5. So I'm going to leave that underneath my cube root. And then I'm just going to simplify that 2 times 2. And my final answer would be 4 cube root of 5. And that would be my final answer. Let's try the next one. So let's start with 48. We can divide that by 2. 48 divided by 2 is 24. 24, we can divide that. Let's divide that by 3. 24 divided by 3 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And we'll stop there because it's a prime number. So again, I'm going to look for all my groups of 3. I have one group of 3 2s right here. So that comes outside. And then I have a 2 and a 3 left over. So I'm going to bring those, leave those underneath my radical. Okay. So now I'm going to just simplify that. I'm going to have 2 cube root of 6. And that's my final answer. Let's real quickly try the last one over here. So we have 72. Oh, this one is the square root of 72. Sorry, this should be a cube root. So if we have the cube root of 72, let's start off, we could divide that by 2. We can also divide it by 3. Let's divide by 3. It should save us a little bit of time. So 72 divided by 3 would give us 24. And again, we can divide 24 by 3 and get 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And we'll stop there because it's a prime number. So it looks like I have one group of 3 2s. And then I'm going to have 3 times 3 left under my cube root. So our final answer, if we multiply those together, would be 2 cube root of 9. So again, the difference here between simplifying a square root and simplifying a cube root is that instead of circling groups of 2 and bringing those outside, we're circling groups of 3 and bringing those outside the cube root. Okay? So the next thing we're going to talk about real quickly is multiplying radicals. You're always going to start by multiplying whatever terms are on the outside of the radical, and then whatever terms are on the inside of the radical. Once you do that, all there is left to do is simplify. So if you look at our first example here, square root of 3 times square root of 6, we multiply the two numbers that are underneath, we get square root of 18, and then we would simplify that by dividing by prime numbers. So let's take a look at the first one, square root of 8 times square root of 24. And let's start by multiplying 8 times 24. So when we get 8 times 24, we get square root of 192. And then we're going to go ahead and divide by our prime factors. So let's see, if I do 192 divided by 2, we get 96. 96 divided by 2 is 48. 48 divided by 2 is 24. 24 divided by 2 is, actually let's divide that by 3. 24 divided by 3 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. Okay? Now I'm going to look for all of my pairs because this is a square root. So I have a pair of 2's here, and a pair of 2's here, and a pair of 2's here. So my answer then, I have 3 2's outside, and I also have a 3 left over inside the radical. So 2 times 2 is 4, times 2 is 8. My answer is going to be 8 square root of 3. Okay, let's try 32, square root of 32 times square root of 9. Okay, so since these are both square roots, we can go ahead and multiply them to start off with. 32 times 9 is square root of 288. So we'll divide by our prime factors again. 288 is actually divisible by 3, so I'm going to start with that. You can divide by 2 if you want, that's perfectly fine. But the bigger the prime number you divide by, the less work you're going to have to do. So I'm going to divide by 3, and I would get 96. And 96 is also divisible by 3, so 96 divided by 3 is 32. 32, we can't divide that by 3, let's divide by 2. So 32 divided by 2 is 16. And 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. We'll stop there because it's a prime number. So let's circle all of our pairs. I've got a pair of 3s. Oh, that should be a 3. I've got a pair of 3s. I have a pair of 2s. And I have another pair of 2s. And then under the radical, we still have a square root of 2 left. So if we simplify these numbers outside, 3 times 2 is 6, and 6 times 2 is 12. So our answer would be 12 square root of 2. Why don't you pause a second and see if you can do the bottom 2 problems. So square root of 12 times square root of 3, and square root of 12 times square root of 12. Okay, so these last 2 were kind of tricky. If you were to multiply square root of 12 times square root of 3, you would get square root of 36. Now, square root of 36 should jump out at you because it is a perfect square, okay? So instead of having to simplify by dividing by prime factors, we know that square root of 36 is 6. Now, if you decided to divide by prime factors, you'd figure out the same answer. Let me show you real quick how you would get that. We divided 36 by 2, we would get 18. 18 divided by 2 is 9. We can't divide 9 by 2, but we can divide it by 3, right? And we stop because we have a prime number. Now, if we were to take out our groups, our pairs, we would have a 2 and a group of 3s, and there would be nothing left over. There would be nothing left over underneath our radical. So our answer would just be 6. Okay? So that's why our square root of 36 should just be 6. You don't have to simplify it down this way because we know that the square root of 36 is 6 because it's a perfect square. Now, likewise, for the next problem, square root of 12 times square root of 12, we would get the square root of 144. Again, 144 should jump out at you because that is a perfect square. So the square root of 144 is going to be 12. Now, anytime you have a square root multiplied by itself, you will always just get that number without the radical sign. So say I had square root of 56 times square root of 56. That's going to equal 56. Or if I had square root of 8 times the square root of 8, that's equal to 8. Even if I had square root of xy times square root of xy, my answer would be xy. Okay? So that's all we're going to talk about for this lesson. Make sure you write down any questions you have if something doesn't quite make sense, and we'll talk about it in class.